Okay, well, let's see. So welcome, everybody. This is a historic occasion. It's the first Pages webinar. I'm Darrell Kaufman. I'm a member of the Pages Scientific Steering Committee. I'm actually visiting the International Program Office in Bern, Switzerland, and I have a special interest in data stewardship, which is one of Page's integrative activities. So it involves all of our working groups across the Pages program. So the steering committee and the IPO have been looking for ways to help working groups and the rest of the paleo community find ways of advancing paleo sciences. And we thought a webinar would be a convenient way and mainly a sort of carbon neutral way of sharing information about topics that are relevant across working groups and the broad community. So we're hoping that this will be the first of many future seminars to come. And I want to thank the IPO and I want to thank Lucian for organizing and hosting this webinar. So I should mention that the webinar is being recorded, so that's convenient for our friends in other time zones. So this will be available to others after the live presentation. Let's see. I did forget one thing about the Adobe Connect platform. On the right side of your screen, you'll see a chat window. That will also be recorded. Please feel free. I think even both presenters and participants have access to that. So if you have questions that come up as Nick is presenting, please go ahead and enter them into the chat. If they seem like it would be good to answer the question as Nick's presenting, we'll try to get his attention so that he can answer them during the presentation. Otherwise, we'll just, your questions will join the queue and we'll get to those after the presentation. We'll have plenty of time for questions. Nick will present for about 40 minutes on the lipid framework, and then we'll turn it to the presenters for questions and to participants following that. And then we'll conclude. I'd like to get some feedback for Pages on the webinar, on the format, and maybe some suggestions for topics for future meetings. So it's my pleasure to introduce Nick McKay. He's an assistant professor in the School of Earth and Sustainability in Northern Arizona University. Nick's situated at the crossroads of a variety of paleo science fields. And so he has a sort of a holistic perspective of paleo sciences that begins with data generation and goes all the way through data curation. He generates records on paleo environmental and climate change, mainly from lake sediments. He uses the information to inform process-based models. He's been collaborating with Pages, the working groups, and others in the community to assemble large data sets of paleoclimate information. And he's the creator of the data container that he'll be talking about today, which is meant to assemble paleoclimate and other paleoenvironmental information. And he's developing the tools to analyze those data sets. So as Nick will tell you, the platform, the lipid platform, really was developed more or less in parallel with the activities of Pages working groups, where there was a need to conveniently manage the diverse variety of data sets that our science involves. The lipid framework is also integrated with the ontology for Linked Earth that's being developed with collaborators at the University of Southern California. And it's also being developed in coordination with the World Data Service for Paleoclimatology at NOAA. So when data are entered into the lipid framework, it's possible that they get transferred to NOAA for long-term archival. So with that introduction, Nick, go ahead and take it over.
Okay, thanks, Darrell. I assume everyone can hear me? Okay, I'm going to see. So bear with us, right, as we sort of get the technology working. Yes. And I think I'll be able to see the chat window, but not much else while I'm presenting. Thanks, everybody, for joining us. This is a great turnout, especially given that it's being recorded and that you could have tuned in later, so I really appreciate everyone coming, and thank you, Darrell, for that introduction. And yeah, so as Darrell says, I'm not a computer scientist or not somebody who 10 years ago would have been expecting to be giving a presentation about data formats. It really is something that sort of has been developed with me and friends and colleagues as we saw a need. So as early as 2010, 2011, I was doing what many of the people here in the room do, is wrangling data sets together to try to answer big questions about paleoclimate, paleoenvironmental things, and just became really frustrated with how much effort that took, how much time it took spending just wrestling with data as opposed to actually doing any scientific work. And so over the past 5 or 6 years, I've had the chance to get involved with trying to address some of these issues, which means learning some computer science and sort of very slowly pushing this forward, mostly with my collaborators at USC, especially Julian Millet, who's a professor at USC, and Deborah Kaiser, who's been there in various capacities and continues to be there as a I don't know exactly your role, Deborah. I know you're here, but in the Information Science Institute, ISI there. And with a lot of other collaborators throughout the community, again, the major goal, throughout the time, we really wanted this to be a community effort and have developed this through lots of collaborations. Oh, I think I broke it. Yes. Okay. I can see my chat now, even though it looks like it probably turned off. I can try to increase the volume of my microphone.
Yeah, so you can find the microphone icon, and you can adjust the microphone volume with that pull-down menu. Also, if you're having a little trouble hearing Nick, he's coming through loud for me. You might use the speaker icon where you can adjust the speaker volumes on the top panel of the window.
Okay, yeah, it looks like I can't access that microphone menu while I'm sharing my screen. So I presume, I guess I could stop sharing my screen, but hopefully it's not too bad. Let me know if it's a persistent problem and people can't hear me. Is that better? You can see me again? Okay. Right, so I just really want to start by thanking everyone who's been working on this with us collaboratively, both conceptually and down in the trenches, especially Chris Heiser here at NAU, who has been doing a lot of the dirty work with what we're doing here. So, okay. Oh, also, you can imagine a 40-minute presentation about a data format can be a little dry. So I did my best to try to include some animations and a bit of variety here. Which means I know that depending on your internet connection and in this sort of format, some of the animation as we're sort of moving around things might be really difficult to see. So bear with me with that. We can make most of these things are either websites or videos that are already online or can be made available really easily, and I can do that afterwards. So if you miss something animation, I can make sure you can follow up with it afterwards. Okay. Okay. So this is the plan for the next 30 minutes or so. We're going through these topics. So just sort of a basic conceptual overview of what LiPD is. LiPD stands for the Linked Paleo Data. It's a data format. It's also sort of a conceptual way of organizing paleo geoscientific data. That's sort of one of the reasons we refer to it as a framework. It's not just a format. It's sort of a philosophy. Second topic is where you can find and what data sets are already formatted in LiPD and ready for you to use and play with. The third one is about what LiPD can do for you, either in the context of a working group, PADE's working group, or as an individual scientist interested in doing science. And then the fourth one is if you have data that you would like to get into LiPD, how to go about doing that. And then, of course, at the end, time for questions and to go back over anything that's confusing. Okay, so first, what is LiPD? And the best way to do this is not through a keynote here. So I'm actually going to switch over to a Prezi presentation. Okay. Okay, so I assume that's coming through well here. Okay, so lipid is a container. That's sort of at its heart, it's a container that we want to be structured in a way that is useful and can organize information, but it's flexible enough to accommodate the variety and different kinds of information that we encounter in paleoclimatology and really more broadly than paleoclimatology throughout the paleogeosciences. So you can sort of envision it as this big black blob here as a lipid file. It's going to have a whole bunch of things in it. And so it's going to have, a lot of this being metadata, it's going to be both data and metadata describing that at a number of different levels. And we're sort of going to zoom around this black blob to explore that briefly. Oh, okay, my fault. Sorry, I was testing this earlier. I think that at the end, there we go. Okay, there's a big black blob. Okay, so first, there's what we call root metadata. This is just this sort of simple metadata that describes the data set as a whole. It's going to have a name. It's going to have some sort of URL where this thing exists. It's going to have investigators. And again, all of these things are really flexible. There's often a lot of other additional information that might describe the data set as a whole. And then there's some other common metadata, which are common to essentially all paleogeoscientific data. So some sort of geographic metadata, something that describes where this is in the world, both in terms of latitude, longitude, and elevation. This could be one point. This could be a polygon. This could be a bunch of points. It likely has a site name. It has some geographic metadata associated with it. So that gets stored in there in a standard way with the GeoJSON standard. There's also some metadata describing publications associated with that. Most data sets have one or more publications that describe it. Again, there's a sort of standard format in JSON for doing this. It looks something like this. It's sort of conceptually similar to like a bib text structure where you're just describing the authors and the title and the journal of each publication. There can be any number of publications associated with the data set. You also may want to include some information about who paid for the research to be done. Again, there can be more than one of these. So that's all relatively straightforward. And then here's the more interesting stuff. At the bottom is where actually the data and then the information about those data are contained conceptually. And we split this into the two common axes that you would think of. You have your time axis and the Cron data information, or at least the information that derives that axis. And then the sort of environmental, the y-axis variability on the paleo data. We'll start with Cron data. So again, to accommodate this flexibility, there can be multiple different, any number of instances of these cron data objects. Most data sets are only going to have one, but there could be more. And within each one of these is a number of different things. There's two sort of next unit down items. There's the measurement tables. This is just like a table of everything that you measure. And then, so we can zoom into this, and just like any other table, it's going to be a sort of tabular format. It's going to have columns, where each row is a measurement typically, and each column is a different variable. So this is a common example. You'd have something that looks like depth. You'd describe the name, the units, and it would have values associated with that. You'd have radiocarbon dates, radiocarbon uncertainty. You could also include some sort of metadata about each row here, and like the material data. What is it that you dated? So this is what would go into a measurement table in the Cron data. But then there's also this other section which is called the Cron model. This is not something measured, but information we really commonly want to embed into a data set. So this might be a methodology. In this case, the example here, and why we start with the Cron data, is this is for age models, is what we're typically thinking of. This is most of us are pretty familiar with. There's often some sort of methodology, right? So here's an example using Bacon. It has some version, it has parameters that were used, potentially has a set of code that was used that could regenerate this. That would be stored as metadata. And then there's a number of different types of tables that get output from that. So one would be sort of the standard, what we call a summary table, something that summarizes the information that's output by that algorithm. In this case, it's going to be some sort of depth. Oh, I guess there's some zoom around here. So some sort of depth, median age, maybe 2 sigma uncertainties, the sort of common outputs that we get there. It's nice to have. That's useful to have, but one of the real powerful things in lipid that makes it pretty unique is that it also has a standardized way of embedding ensembles. And so a lot of uncertainty quantification in the paleogeosciences rely on ensembles. This is true for many of the Bayesian techniques, Monte Carlo techniques, and really to take full advantage of these ensemble-based methods, we need to include the full ensembles, not just statistics from them, so we can then propagate those ensembles through all the analyses going on. So we need to store those somewhere. And we do this in the ensemble table. And this would look similar. There'd be depth in a column, and then there'd be, say, 1,000 additional columns of different instances of an age model. Each of them are sort of equally or comparably likely, and then we can sort of assess how uncertainty in the age ensemble, uncertainty in the age model would then propagate through our analyses. I'll give an example of this later. And then lastly, we can also store irregular distributions, like radiocarbon distributions, as a distribution table in these sort of model sections. Okay. If this is all seeming complicated and uninteresting, that's fine. You don't have to understand any of these details to use LiPD. Most people never need to dive in. We designed it so that users can take advantage of these features without necessarily understanding them, but it's nice to have a conceptual overview of what's possible. Okay, and there can be more than one model. So say multiple different publications are associated with different age models, then that can be embedded here as different models. So there's a lot of flexibility. And again, this is a representation which is more complicated than most data sets end up being, but that's possible. Okay, the paleo data section mirrors the Cron data section. It's the same structure, it just has a different focus. Instead of it being information or measurements about chronology information, trying to determine the age, it's measurements about paleoenvironmentals, whether that's climate or ecology, that would go into here. But it has the same structure. There can be multiple paleo data objects. There's measurement tables and models. Let me take a little, zoom in a bit about that, and then also highlight a bit some of the more nuanced metadata that sometimes gets incorporated with this information. So here's an example where we measured, somebody's measured depth. Here's the age inferred. This could be brought over from the chronology table. And then we have a couple of different columns of sort of measured information, which is inferred from it's inferred paleoenvironmental variability. So this case is delta 18O. We note that it's a measured variable, but it has an interpretation. So there's a couple things in here. We can say, okay, yeah, this has a climate interpretation. This is embedded at this column level, and it can say that this has been interpreted by the authors of the paper as an effective moisture. It's integrated over the course of the year with a negative relationship. So higher values of delta 18O corresponds to lower values of effective moisture. So a negative relationship. This is sort of tongue-in-cheek basis, but this could include a quote from the paper, something that describes why they think this to be true. You could also include something that's a bit more formal in terms of interpretation. For example, a whole bunch of information about a proxy system model, something that describes more quantitatively and more mechanistically how this is, the connection between some sort of environmental variables and the observed proxy data. We could also have an inferred variable. So note that the variable type in column 4 is now we've inferred precipitation from this. It's no longer measured. We didn't measure precipitation. It has slightly different climate interpretation. This time it's variable. It now has a positive direction, a slightly different seasonality, some sort of basis from that, and so on. So one of the key features of sort of fundamental tenet of the framework is that to be able to describe metadata at any level in the data set. And that's commonly most powerful at the sort of column level, to be able to really encode some nuanced interpretation of each variable that's been measured into the file so that gets passed on and can be used later for analysis. Again, you can also have a model for this, right? So if you have some sort of reconstruction method which outputs an ensemble or other sorts of uncertainty quantification for the paleo data side. So as you're estimating precipitation here, there may be make an ensemble output that can be stored here as well in the same way. Any number of those. That would looks conceptually similar to the age model description. Okay, so that's it. That's maybe a lot, but that's the idea here, and the idea is it's all about being able to having the structure to know where things are and have a place for most of the concepts we want to use, but also have the flexibility to expand that. Okay, let me come back over here to this. Okay. So I've already emphasized this, but I just want to repeat that. And so lipid it's a container. It has structure to it, but the terminology associated with it, with a few exceptions, it isn't prescribed. But it works best when you're using some sort of standardized terminology. The two that we're working with most closely with lipid is the linked earth ontology, which is really built sort of in companion with lipid, and that describes the relationship between different variable names. It standardizes some of the variables, gives them controlled definitions, also connects it to the semantic web, and so Google dataset search and other things like that. Other one is the Path Thesaurus, which is the collection of standardized terms for paleoclimate data developed by the World Data Service for Paleoclimatology at NOAA. And these are really complementary, where linked earth ontology is describing more terms and the relationship between them. Path Thesaurus is more standardizing the sorts of answers for those terms, the kinds of words we use to describe, say, the delta T-no of calcite or something like that. Okay, moving on to the second topic here. That's all great. So for the rest of the talk, we're not going to be talking about all those nuances of the structure of lipid, more just about what data are in it, how it's used, and why this might be useful for you. So there are a few thousand, probably about 3,000 now in total data sets that have been structured into the lipid format. Probably the most well curated and high profile of those data sets is the second version of the Pages 2K temperature database that was published in Scientific Data last year. Here's the sort of summary figure. It's 692 records from 648 sites from a whole collection of different types of archives for the past 2K. This is one of those projects that, this version and the first version, lipid was sort of developed as a companion to these efforts, and certainly expanded beyond that. But it was sort of this, they sort of mirrored the development alongside each other. So these data are all available as lipid files from a few different places. First, you could get that whole collection directly from the World Data Service for Paleoclimatology, NOAA. If you go to the Pages 2K page, you find this. There's a spot data folder. You click there, you can find it in the sort of standard NOAA format, but also as lipid files. The World Data Service has been really great in working with us. They're really happy to, as a companion to their templated version dataset, it also hosts lipid files themselves, and they're really eager to work with the community and on making the data as valuable as possible. This, is an animation that's going. So another place where you can find lipid data is at the Linked Earth Wiki. This is a bit different. So this is a wiki format. It mirrors the structure of Wikipedia, but it's also connected to a semantic backend. All the Pages 2K data are here. You can download lipid files there. You can also comment on things there. There's a discussion page you can see sort of in the top right there, like you would with the wiki. You can edit. Once you're a user, you can propose or make edits directly to if you find mistakes, whether it's in this or in other data sets. So that's another source. And the third source is more of a sort of informal collection of lipid files called at lipidverse.org, which is sort of a cheeky name that we made with the idea that if you want to go sort of find all the lipid files that exist that have been shared that we can make available, you can find them at the lipidverse. It has this sort of interface where you can navigate around through different collections. What you find now, if you go there right now, would be the Pages 2K up front. The idea is that within the sort of next several months, that this would become much broader and include all of the data that's publicly available, and also contributions from people that are formatting data on their own, just to have sort of an easy access place where you can download a whole collection or individual files. You can navigate through the metadata, see what the data look like. This is on GitHub on the back end, so if you just want to sort of sync your computer every day with every lipid file that exists, you could do that. So that's the goal for Lipidverse, which is a sort of a new thing, which is we're still very much working on. So this is a map of about, not quite all, but most of the data sets which I know about, which have been formatted into lipid. It's about 3,000 sites. mostly Holocene and 2K data sets, but it's really growing to be quite a nice, large library. And again, the idea is that all of this and more, as people continue to contribute data, will be included in easy access through Lipidverse and elsewhere too, also through Linked Wiki, through Paleo, probably more on a site, on a study-specific level. This includes data from ISO2K, which is being formatted into Lipid as well as the Arctic and NAM2K projects. A large Holocene dataset project with 500 or so records that it's continuing to grow and is being released, and much of the ITRDB, including data from a project from Toby Alt and Scott St. George, where they're including multiple detrained versions of ITRDB. All of this will be in Lipid and available, as things come online, and hopefully more and more as more people use it. Okay. So the third topic now is what Lipid can do for you, and you're probably, if you're here, you're probably approaching this from one of two perspectives. You're either working in the context of a working group and you're wondering whether or not this is a good solution for what your working group's trying to accomplish, or you're here as just sort of individual scientists working in small groups and wondering whether this is potentially a more useful workflow than what you're currently using, or maybe both. For many of you, it's maybe both. So I'm going to start with working groups and going through sort of how we've used Lipid for working groups in the past and how it might be useful, and then talk more on sort of individual level afterwards. Okay, so these are sort of the main features of using Lipid and the tools we've developed for Lipid as a working group. So the first, and again, this is because it's really, the development of this really mirrored the structured. Yeah, thanks, Julian. Really mirrored the 2K project. It really was built for these sort of large group crowd data curation projects. So we'll go through these one by one. So the first one is crowd curation. And for this one, I actually thought it'd be most useful to work through the ISO2K case study, partly because ISO2K came online sort of after the Lipid framework was pretty well set, and we had a better idea of what we were doing. Okay, so a few things with ISO2K. When ISO2K really started, we recognized that there was a lot of metadata that we wanted to include, that the leaders of ISO2K wanted to include in the Lipid file that didn't already exist. And this is great because we want Lipid to be really flexible, really accommodating for whatever it is you want to describe, if it's much more detailed than what we typically would have done in the past. And so we started by defining a bunch of terms, figuring out how to fit these into the Lipid structure. But again, this is sort of infinitely expandable. I feel really confident about sort of our capacity to handle pretty much anything you can throw at it. And so as a working group, you get together and say, okay, I know none of these things are things we've done before, but we want to encode all this information. How do we do this? And so this can include things like descriptions and examples. This is an example of some really nuanced and nitty-gritty isotopic interpretation information that's been included in ISO2K. Once you've done that and sort of set the structure for that, we start collecting data and metadata for files, and then relying largely on sort of shared spreadsheets through Google Sheets to curate metadata. And so we end up with these really large spreadsheets. They're kind of unwieldy, but at the same time, it gives you everything at the same place. Anyone can edit it. You can go through all this interpretation, all these nuanced metadata that you had decided you wanted, and then actually doing the hard work of filling those in. And then we can on the back end sync this with all the Lipid files that the data manager would be coordinating. I will say that this has mostly been a handful of people, and more specifically, it's mostly been me that's doing this. The tools that have been developed for these sort of large scale projects are not as shiny and polished and bug free as some of the other stuff we developed. And so, I'd like to really have to work with people that want to be the data managers, but I'm really keen to do that. So if you are a data manager or want your data manager to be doing things like this for your project, have them get in touch with me, and I'd really be happy to sort of do some training to get people up and running with how we do this with Lipid. So this is what we did for ISO2K for the most part, although we've been working on ISO2K now for 3 or 4 years. And so in that time, sort of crowd group data curation is also available through Linked Earth, through the Wiki format. This works really well on a site level. So if you want to edit information, a data set at a time, it's a wiki. Pretty much, people are generally familiar with how to use a wiki, how to edit it works really well. If you're looking at larger scale types of edits, you want to be able to go through many data sets at a time. It can be a bit more tedious, but both options exist and they're compatible back and forth. And then the sort of last step here of why this, of what you can do, and for this with crowd control is, or not crowd control, crowd curation is quality control, which we've done again in another different ways. I think that this sort of new lipid-verse tool and visualization is pretty effective, where you can get a pretty good look at the data, different columns, different information, all the metadata. You can download the files and explore them more, and also report issues to the data manager directly through this. And hopefully that's going to continue to develop. Okay. The second thing that's really nice about doing this, again, this was the point at the beginning, was that sort of automate as much as possible, minimize as the data sets themselves are changing on a daily or monthly basis over the course of several years, over the course of these projects, is being able to automate your workflows, and each time the version of the data set increases, you essentially just rerun a set of code which produces sort of overview figures or analytical figures. So here's an example. I'm showing that this is a website that was produced in R as part of R Markdown. So I'm going to highlight these a few times. I think one of the really great things about having standardized formats and the tools is that it connects really cleanly to being able to standardize and share information about both about reproducible science, right? So anyone could come on, try to rerun this. So here's an example. This is sort of a live website. And the kind of analysis you would do. So you load in some libraries that handle reading and writing and some of the visualization. You could load in a folder of data sets. In this case, these are a whole bunch that have age ensembles. And what we want to do is an age insert in PCA across this data set. We come down, we take all the age ensembles with this command. This file exists, and you're welcome to try reproduce this through Geochrn R, or just take a look at more detail on this on the website later. We go through a handful of steps to pull the age ensembles through, convert the data to a format that's a bit easier to work with on large scale analysis. You can filter these for various pieces of metadata. In this case, we want to filter this for variables which are called D18O, so we want just the delta 18O data. They all have different time resolution, so we're going to go across all of the ensembles here and bin them into 5-year averages, and then run this across all the age ensemble members to calculate, to do a PCA analysis on a covariance matrix and plot the output, right? And so again, this is the website. This is and as say each version of the data set kept growing or changing, and we're working with different with an improving quality of data, size of data, you just keep rerunning this, update this website, update this workflow, and have these sorts of analyses available as part of your working group. Okay, and then the last step is another one, which is one of these things that you don't think about when you're starting working in a working group, but ends up being a ton of work on the back end that we've done a lot with Lipid for, is when you're ready to publish this as sort of a data publication or as a in a paper, and you need to take your several hundred data sets and produce a bibliography and archive those data somewhere. Lipid can really help with that. So one of the things that's set up, we have code that parses DOIs and populates publication information into the Lipid files. This is really nice. It's only as good as the DOI database, which is sometimes buggy, but it works. There's also some code that can sort of take a bunch of Lipid files and produce a .bib file, and BibTeX can do bibliographies. And then we also have a utility which will take a Lipid file and convert it into the NOAA text format for long-term archival with the World Data Service for paleoclimatology. So all of these things can make your life as a data manager for a working group much easier. Okay, change gears, and now think about why Lipid is useful for you as an individual. And there's a couple things that it does, right? It's addressing this initial concern that me as a PhD student 10 years ago spent most of a year trying to get a whole bunch of data sets together to do analysis. This is becoming much more easy, and hopefully will continue to become easier as more and more data become available in this sort of structured format. And then there's also, once you have data in a format, it becomes really easy to write code, to write tools that use those data for analysis and visualization. So again, a couple case studies. This time, instead of the website, I just recorded a video of what this sort of analysis might look like in R, and I'm going to start that in just a second. And what this case study is sort of one of the existential states of being a paleoclimatologist is that you want to plot a bunch of data in a stack on a line, either for a paper or just to sort of see them. And again, this is the kind of thing that can become much easier. So let me start the video here. Okay, so load in some libraries to do the loading and plotting. You can load in a file of data, this time the European part of the 2K data set. Extract these into what we call a time series object, and then sort of flattens them out, and then another step which flattens them out even more, and then we can do this sort of interesting thing and start filtering this for the data we want and visualizing it. So this takes a minute here. And then you can say, okay, I only want I want to extract all the data that are between the years 1600 and 2000, and the data sets that are between 0 and 50 longitude, 20 and 60 latitude. I only want columns that have been interpreted to be temperature, and then I want to arrange this by archive type so that the sort of order of the plot is going to be structured by archive type. Create this data frame for that, and then you can use this function, plot time series stack, with that data frame, and it will sort of do that. What would be some time, potentially a lot of time in Illustrator for you. In this case, it's colored. Each data set, each time series is its own color, but maybe you'd rather color it by something more useful potentially. There's a bunch of options to customize how this looks. In this case, so I'll type in here is archive type. In this case, we just tell it to just color by archive type. And you get sort of a pretty useful, decent looking plot really quickly. Again, it's the kind of thing we envisioned originally, is that, man, it'd be nice to have this data nicely formatted so we can sort of quickly do these analyses, which would take us a long time otherwise. Okay, and this is part of Geocron R, which is a package in R that Julian and I and others have been working on that reads and writes lipid data, enables ensemble data analysis, and also visualization of things like this, which without any ensembles at all. Okay, so second case study. Yeah, there's a link to this if you want to sort of see more options, examples of what that looks like on Lipidverse. Another example from Geocron R, this case is age-uncertain regression. This is actually mirroring a paper that I was involved with several years ago, where we wanted to do a calibration in time of the data set from Northern Alaska, but we wanted to incorporate age uncertainty into that analysis. And so again, here we're back in this notebook view where we can document this and make it really, make the methodology really reproducible. In this case, we're going to load in this file from Krupa Lake in Northern Alaska, in this study by Bolt et al. In 2015. We can just sort of do a number of things here, and I'll kind of skim over this a little bit. But you can just sort of plot this, get a quick sense of what's inside the data set. We see there's this LiPD data we have to plot, the metadata and the citation, and see where it is in the world. We see there's some ages, a combination of some surface ages and some radiocarbon ages going down in depth. We can create an age model in Bacon if it doesn't already exist in the file. So run this through. There's a number of options. It just really is just running Bacon in the background and storing the ensemble output for you. Once you have the ensembles, plot that chronology. So here's another view of the age model here, with this being the surface. You can see the radiocarbon and the irregular distributions, and then 5 different age ensemble members are plotted on top. What we want to know is, okay, we want to calibrate this with some local instrumental data and understand how uncertainty in the ages are affecting both that calibration and then the subsequent reconstruction going back through time. So it sort of walks you through how you would do that. You can grab the age ensemble, you can grab the LiPD data that you want. You can deal with converting units back and forth, because once we know the units, it's relatively easy to write code around structuring those. We can load in some instrumental data. and calculate an ensemble correlation, and you find that, okay, with the age uncertainty, there's a chunk of them that are significant, about half of them are significant, about half of them are not quite significant. That's okay. We decided to go ahead anyway and move forward with a regression and do the same thing where we're just going to regress the data and do a reconstruction across different age uncertainties and see how this uncertainty affects this regression slope, the coefficients that come out of that regression, and then ultimately this calibration to temperature back in time. And again, the point is that these sort of whatever 20 steps that are listed here was a lot more straightforward, a lot more reproducible than what we did back in 2015 when we were working on this analysis originally. Okay, so another example. This is just two. There's a bunch of other tools that sort of speak lipid, right? That read and write lipid. So Geocronar is the one I've been showing you. The other two that are sort of, I think, best developed at this point are PaleoClim, which is a package for paleoclimate analysis in Python, which reads and writes lipid, developed by Deborah Kiter and Julien Auger at USC. And then also C-Science, which is a package that facilitates age model development, developed by Liz Bradley at UC Boulder. Both these you can read and write lipid. But I think a really important point is that because the hard part of developing all of these was developing a structure which is standardizing that works. And so now that we have that with lipid, it becomes really easy to write tools around that. Once you know where to find the information you need for a tool, it becomes much easier to write code around that. So if there's something that these things don't do yet, that'd be great for other people to continue developing things and develop tools that fit their needs that can take advantage of reading and writing capacity for lipid that exists in Python and MATLAB and R. Okay, last subject, and this one it will be fast, I promise. I know we're getting to 45 minutes here total. Okay, so if you want a data set in lipid that's not already in lipid, I think the best way to do this now is through the lipid.net. So we have a website, lipid.net, has information about lipid in general, but also has this playground which lets you load in lipid files and edit them in a convenient interface. It also create files from scratch. And so you don't have to worry about the details of this. I'm showing a fast-forwarded recording of me creating a file here. And sort of see, you're going to go through and you're going to fill out this information. You can add information about funding. You can add publications. You're going to see the DOI parser in action. You can just paste in a DOI, push autocomplete, and it fills out everything, which is really fun. You put in geographic metadata. After you've added all this, you'll check the map, make sure that you have this right, that it shows up on the map where it's supposed to be. It'll keep track of these sort of warnings and errors along the way to make sure that you're producing a valid file. And then you're just going to go through and enter data and describe those things. So you can, there's a couple different ways of getting the data in. You can paste in a CSV file, or you can actually there's a sort of interactive spreadsheet mode, which is just kind of like Google Sheets, where you're pasting in data, and then you can go through each column and describe all the metadata that you want for that. So videos for this, and you can actually just go check out the website. There's sort of a number of different ways to sort of walk you through this. There's a lot of information in lipid files, and so it's can be a little overwhelming to try to figure out how everything goes in first, but we're doing the best we can to try to make this as user-friendly as possible. And we're also really appreciating and welcome feedback for all these things. We're sort of developing these the best we can, but everything gets much better when we get feedback about, hey, this would be really useful, or this was really confusing. That kind of stuff's really great. The other situation is that a lot of times there's data that's already in some sort of structured format, and there's maybe several dozen or hundreds of files that are you'd be interested in converting over to be compatible with other lipid data. This is great. We've done this in a number of different ways. There's a function in Geocronar which will convert data from Neotoma into the lipid structure, and we've worked with SQL databases and converting those over to lipid, in a couple of different capacities, and with other sorts of standardized format. Even if it's just sort of a standardized set of Excel files, if there's enough data, then it's almost always much more efficient to just write some code that converts that into lipid than it is to recreate all of those. So if you have a whole bunch of structured data, definitely get in touch with us and let us know, because it's probably much faster just to do that automatically than to try to re-enter things manually. Okay. And then I sort of just, lastly, is that once you have those data in that in format, please share them. Again, the point of this is that we don't have to keep reinventing the wheel as a scientific community, that we as a community can spend more time doing science and less time wrangling data. And so again, the World Data Service, Linked Earth, Lipidverse are all places that you don't have to pick one, where we can share these data, make them available more broadly, and sort of accelerate scientific progress, hopefully, throughout the community. So we really value your feedback and your input. And again, it's the point is to essentially be more efficient and get more stuff done and spend less time with a lot of the TDM that I've been describing over the past half an hour. So I just want to finish with thanks to all the people that have contributed and have been collaborators in the development of this, especially NSF and Palo Center, who funded some of the development of this, and then all the work through Pages and the 2K network, and sort of bearing with us as we worked out the kinks in this over the past half decade. Dearth, Noah, these all folks. Okay, that's it.
Okay, Nick, thank you so much. I guess we don't have an applause function on Adobe Connect, but that was super informative. We got a lot out of that. So at this point, I would like to invite those of you who are listed as presenters that are representing working groups. If you want to go ahead and open up your microphone and open up your webcam, and I think it would be most efficient just to go ahead and speak up. And if it gets a little confusing, I'll ask folks to raise their hands. If you're a participant in the lower section, would like to ask some questions using your microphone, go ahead and raise your hand. Otherwise, we've got some activity on the chat side of things as well, and we'll monitor that so that we can get the questions answered. But we'll go ahead and start with the working group, so take it away. Paul, I see you have your hand up.
Yes, I thought.
Go ahead.
I thought I'd better get started on this. Hi, can you see me?
No, but I can hear you.
Oh, okay. I'll start sharing. Maybe you can see me now.
Yes.
Okay. Yeah, so I represent a couple of the Pages projects, which are really about paleo data in the North Atlantic, and the use been really about high-resolution marine archives, which haven't really started to get into Linked Earth yet. And there's a few representatives of these groups here already, so maybe they'll chip in as well. And maybe it's just possibly something to do with the getting started, and whether I can just go to the playground and put a bit of data in. I suppose I can, but I don't have the metadata formats, which look a little bit more complicated, that you've been demonstrating, for example, for ISO 2K. So shall I really get the format set up first before we start encouraging people to put data in?
I mean, some of the standardized stuff that we've done, I think, is pretty good for most sort of general paleoclimate applications. So it's possible that the terms you'll find in there, one of the things I didn't mention is that on the playground, the terminology is connected to the terminology on Linked Earth. And so if it's something that somebody's entered before, that'll sort of pop up as an autocomplete option as you're going through, and it's likely that you'll be able to, I think, fit most of your needs. There's definitely a learning curve, right? And it's I understand there's this investment time where things become less efficient when you're first trying to figure out how to do these things, and you end up saving time in the back end and trying to figure out that calculus is something that we all do. So yeah, I would encourage you to go to the playground and see if you can sort of walk through the tutorial and try to enter a data set. And if you find places where you say, I really want to encode this information somewhere, I'm not sure where to put it, let us know, and we can let you know whether there is a place for that already, or whether we should be thinking about developing something new that's really specific to these to these records that you're having. It'd be great to have that conversation.
Well, we have as a community started to have this conversation, and we're going to have a meeting in a couple of weeks where I think we'll discuss it a little bit more. And at some point, though, I'm thinking about having a meeting like this, really, where someone like you would actually give us direct advice on how to put data into the to the system and then use it.
Yeah, I mean, we'd be happy to help with that. I mean, what would be great is if your community says, okay, these are all the pieces of information we need to know, and just let me know that, and then I can sort of work through you and say, okay, yeah, this is where we store information like this, and this is where we store information like this, and oh yeah, we've never had to deal with that kind of information before, but this would be a logical way of embedding that somewhere. Yeah, I'd be happy. I mean, myself or others involved would be happy to help you with that.
Great, thanks, Nick, and good talk, by the way. Thank you.
All right. I'm going to come back on the scene here as well. If you maybe after you ask your question, if you could go ahead and mute your mic, there can be some feedback. So it's best to ask the question and then mute. And Gene, I see your mic is on. Why don't you go ahead?
Thanks, Darrell. Can you hear me, guys?
Yes.
Yes.
Okay. Do I need to turn up the volume at all or anything? Okay. First off, thanks, Darrell and Nick. Thanks a lot for that great presentation. I see in the chat clap, 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 and so I want to reinforce that. I wanted to mention that Nick talked some about the translation from LiPD into our NOAA template standard. And there are aspects of that, especially with regard to the new controlled terminology that Nick was talking about called PATH, or Paleo Environmental Terms. I'm sorry, Paleo Environmental Standard Terminology. There are certain aspects of that translation that are still a work in progress. We want to encode that metadata. That's about what's measured variables, and we have 10 categories here that we're now also using to drive a very sophisticated set of searches. And so some aspects of that are still a work in progress. So when you want to contribute LiPD to the World Data Service, just please contact us at paleo@noaa.gov, and I'll write that into the chat so that we can work with you to make sure that we get the full metadata here and make sure that the translation works as effectively as possible. So we just wanted to mention that, and we're working on that, both Nick and the LiPD people all together, and us, we're still working that out. Nick, did you have any comments that you would like to add in that regard?
Yeah, I mean, this sort of goes back to that distinction right at the beginning between that LiPD is a data container, and you can put whatever you want into it, but there's also these standards. And so to make it compatible with what you guys are doing with the past Thesaurus, you have to accommodate the standards. So if you follow the standards, then the conversion should work really smoothly. But there's nothing, we're working on ways of making that easier to help people that want to create a LiPD file which will be compatible with those standards to do so.
Right.
So
that's what I'm saying, and that's still, to a certain degree, a work in progress. And again, from our perspective, we're trying to get all the metadata we need to drive this completely new search capability that we put into effect. And so anyway, paleo@noaa.gov, and I'll write that into the chat. And Darrell and Nick, thanks for, we've been listening, and thanks for giving us the opportunity to add here.
Great, thank you, Gene. Okay, other representatives from working groups, please go ahead. Thomas, if you want to mention which working group you're with, that'd be great. Take it away. So you'll need, your mic should be on. So we're not hearing you now.
I know. Now you should hear me. Yeah, perfect. Yeah, great. Yes, I am working at the Federal Institute of Hydrology in Germany, and basically I'm leading the Pages working group, which is called GLOSS, which means Global Soils and Sediment Transfer in the Anthropocene. And we are basically in the stage that we compile global data on soil and sediment transfer, and we are interested how humans have impacted soil erosion rates, sediment transfers in the rivers, on the hill slopes, and into the sea. So we get all these issues that the spatial configuration is very important, because we have realized that it's not just enough to have a point data, make a drill in a lake and just analyze it, but space is very important information, because as typically soil is eroded on the hill slope and then it travels all the way down into the upstreams and then into the larger rivers, is stored several times for longer periods of times, remobilized, and then finally flushed into the sea. But between erosion and final storage in the sea, there can be thousands of years. And yes, and we are interested how this how the human impact, or how human impact have changed environmental systems on the hill slopes, which basically react very quick and compared to river system, especially a larger river system, who would have a very delayed lag time of, as I said, several thousand years. So spatial context is very important for us, and the question is, how can we deal with spatial context in the LiPD environment? So basically, of course, first of all, thanks very much for this cool explanation, and of course, thanks very much, Darrell and Lucien, for organizing this. This is perfect, and I think this is what is needed. But from my point of view, how can we deal with the spatial context here in this LiPD environment?
Yeah, good question. It's so for the geospatial information, we use this standard, which is called a GeoJSON standard, which is a fairly well-known sort of internet standard. We, like you said, most of the time it's sort of points, but it's possible to include other types, including polygons into that, or even multiple polygons. This is something we haven't really, although it's possible, we built in the capacity, this isn't something we've really explored yet. And so so it's certainly possible to sort of embed a polygon instead of a point. Now, if that polygon is like changing through time, or same with the lag information, that could certainly be embedded as metadata or as a time-dependent variable. Changing geospatial information through time is something we haven't dealt with yet and might require a bit more creativity. Something that also should be clear, although we've done our best to make this really broadly applicable, it's entirely possible that there's, it may not be the ideal solution for every problem. So we don't, the goal isn't to try to fit a round peg into a square hole here. But I do think that we might be able to accommodate that. So I might have to, it'd be great to chat with you offline or some other time and think about whether or not this is something that would be readily accommodate it, and also does not accommodate it, but that it would make it work with some other tools, right? Because right now, even though you could embed a polygon or multiple polygons for your geospatial information, none of the tools, at least that I've developed, and Julian, you can correct me if I'm wrong, but my hundreds of other ones too, aren't sort of set up to like map polygons automatically. But that's something we could build if there is a demand for it.
Yeah, cool. Thanks very much. Basically, we should then talk to each other outside of this webinar here. Yeah, cool. Thanks.
Great. Thank you for the question, Thomas. I think, Franziska, that you had your hand up next. Go ahead and unmute your mic, and away we go.
Hi. Thanks, Nick, for this great talk. I am here representing the Spatial group, so the Speleothem isotope synthesis group. And we basically built our own database of Speleothem data, where a lot of things look kind of similar to what LiPid is doing. But I had two questions that were kind of also brought to me from my working group. So the first is, during your presentation, I wasn't sure if you have a future, or a record that is superseded by a follow-up record that is maybe higher resolution or has a better age model. Can you just add that to the entry in LiPid?
Yeah, so there's a couple different ways of handling that, and it depends on the nuance. But yes, so you could incorporate multiple age models and then connect them to different publications and new data. So you can definitely include them like as part of the same one, which probably makes sense in this case, right? If there was like a spatial study, people had measured a bunch of stuff and then they went back to the same sample or another spatial in the same cave and then extended the record, you might want to incorporate that into its own data set rather than a separate one. And this is something that we've done. There's a number of different ways of approaching it, but that's kind of with the sort of all the sort of subtle variations of how that can happen. But yes, this is something we've done before in the past. This is also relatively common in marine sediment studies where the same core gets measured for many different things by many different people over the course of 20 or 30 years sometimes.
Right, yeah, that's cool. And then the second question is a bit more broad, but in terms of the lifetime of the lipid project, what's the timeline and what is the long-term archiving? So you talked about NOAA, but that seems like that's something that the user has to do, like archiving the data at NOAA, or is that something that the lipid data, the project does?
Yeah, that's a really good question. So we are now past the sort of the development of lipid was for the most part funded by the GeoCronar project and the Linked Earth project, both of which are essentially over now. And the goal, neither of those have long-term funding to be repositories, long-term archival repositories, which is one of the reasons why it's so important, and we really value our relationship with NOAA, who is funded to do that, and have invested in trying to make that conversion as functional as possible. So as currently constructed, you can take a lipid file, you can push a button or run Python code, and it converts it into a NOAA format. Whether or not it meets their standards depends on how you handle the terminology in the lipid file at this point. So that is sort of currently, yes, you would like generate that and then email it to them is sort of the structure. So in terms of, I mean, I can imagine, I think ideally at some point, if it's working really well, there'd just be a button, right? So you'd create your file, and then you'd download it, and then it'd be like send to NOAA Paleo, and it would open up another window, and it would walk you through that process. We're doing the same thing with Linked Earth. So in terms of the lifetime, so even though it's not funded, it's now at a pretty stable point, and it's as much of a scientific venture for me and my colleagues as it is sort of a development one, non-technical development one. So I think that it's going to continue to be supported and developed for the foreseeable future because it is relatively stable. The tools that we are using with it are relatively stable. It doesn't require a ton of attention and investment. It's more just sort of maintenance. With the idea that, this is going to be something that's going to be maintained as a community effort by Julian and myself and colleagues, and hopefully a broader community as more people are using it. Everything's open and accessible, and I really would welcome sort of this being a community effort that moves into the future with or without funding.
Okay, great. Thank you very much.
Hi. Hi, Darrell. We could not hear you. I think your mic is off. But I guess it's my turn.
Thanks for picking up on that.
Okay, I guess it's my turn.
Thank you for taking the initiative. Go ahead.
Hi, I'm Alessio Rovere. I'm representing PALSI, Paleo Constraints on Sea Level Rise, and we mostly work with Paleo Sea Level data sets, so Paleo Sea Level proxies. Now, what you described, and thank you so much for doing that, for giving us this presentation, is basically something that I see working fairly well when I have, let's say, samples with a one-to-one relationship with ages. Let's say I have one sample, one proxy, one sea level interpretation in my case, and one age of that. But a problem we have, and this works very well, for example, for Holocene sea level data sets. But the problem we have is when we have multiple relationships between different tables. Like I have one site, 5 samples on that site, and maybe 3 ages for each one of these samples obtained with different sampling, with different dating methods. Do you think it can be, I mean, do you think it's something that can be told to do something with linked or not?
Yeah, good question. So again, yeah, for the most part, this it was designed with continuous sequences or sort of semi-continuous sequences in mind, and so the sort of the cases where you have some sort of observation that's sort of discrete, associated with some discrete chronology measurements, is a bit different. I need to think, like, walk through an example.
Okay.
My hunch, I can imagine a couple of ways that we could take advantage of the ensemble tables to incorporate sort of complex uncertainty structures in the chronology that come from multiple sources. But I'd actually have to work through that. So be interesting. I'd be really interested if you'd be willing to send me an example sort of data set, and I could think about that and whether this is something that makes sense for lipid or not.
Okay, thank you. Yeah, we have tons of Excel tables as you were showing us. So we're working with Excel mostly right now. So anything is better than that.
Okay. Yeah. My hunch is that it may not be a perfect solution, but it might be better than most of the other solutions that are available to you.
Yep. Thank you.
Great. Thanks for your question, Alicia. Bronwyn, I see that you're still here. Please go ahead.
Yes, I figured my student is running late who I'm supposed to meet with, so I can just chime in for a quick second. So I just wanted to say thank you to Nick and Julian and everyone else involved in Lipid for deciding to do this before ISO2K started. Because I think basically you managed to cut off probably at least a year of time that we would have spent struggling to figure all this out on our own. So thank you for that. And just a quick word to other groups who are interested in adopting Lipid for some of their own purposes is that if you are considering adding new metadata fields, which is something that ISO2K has been doing extensively, as Nick mentioned, I definitely would recommend that you just start now and don't wait for someone to show you how to use, I think there's a lot of resources out there already that Nick has shown. Just try it out, because the process of developing metadata is actually more of a conceptual process than a technical challenge. The technical part is easy. It's easy because Nick does it. But the harder part is actually agreeing on what different terms mean and how you want to lay them out. And that's a really bigger picture conceptual issue to deal with within people in your field. So try it out, and then you'll probably end up iterating with Nick on how to approach it technically, and then you'll see the result and realize your conceptualization was maybe not what you thought it was, and it'll probably be a back and forth process. So go ahead and start on it now.
Yeah, absolutely, Bruno. Yeah, it's deciding what terms you want, the definitions for those terms and the relations between them is by far the hard part. And it's also like it's adding terms, and is pretty trivial on my side, but making them useful, which is really more the working group's responsibility and something I can't really help with, especially for a field I'm less familiar with.
Great. Thanks, Bronwyn, for those insights from the ISO2K side. Okay, another hand. Julie, you're up. Go ahead and mention the working group that you're in, or, oh, CPEAT, there it is. Go ahead.
Yeah, hi, can you guys hear me? Oh. Can you hear me? Yeah? Yes, hi, I'm Julie Wazel. I'm representing CPEAT today, and thank you, Nick, for this conversation and this nice talk. So a couple of things. We are, of course, working on our own databases as well, and we have a few scripts, not scripts, we have a few templates that I think we could probably write some scripts with you and find a way to ingest all of our data into Lipid. I think that would be something that we would love to do, certainly, and we can talk about this offline later on. Cool. But some maybe potential issues, or not the issues, but technical challenges would be things like, so if we have a time series like a delta 18O that you've been showing us, that's a pretty straightforward type of data to put into your data set. But when we have things like inferred data sets, like a water table depth reconstruction that is based on an assemblage for each one of the depth layers, of course, we have Neotoma where we can put all of the raw data, but could there be some kind of a script that reads across Neotoma and then into Lipid, so that this way people could play with the different transfer functions, for example, based on the data set? Or how do you envision those types of more difficult data sets?
Yeah, so yeah, as you highlighted, Neotoma is really much better. They're much better set up than Lipid is in general for taxonomic data, but they can play. They play nicely together. And again, Neotoma doesn't traditionally house the interpreted or modeled output from that. Mm-hmm. And so absolutely, yeah, this is the idea of having those models and model outputs embedded in Lipid. So there'd be the measurement data, which would be the taxonomic data. And then you could have multiple different models with different transfer methodologies, which are producing outputs, which are these inferred variables and their uncertainties potentially. That's just sort of associated with a code base that's that does that calculation and is able to reproduce that. That's the idea, absolutely. That we're well set. That's sort of at the heart of one of our goals. Although in practice, I don't know if we've actually done that yet, but we're sort of set up technically to do that.
Great. Okay, that's good. And maybe something also technical in terms of criteria, or do you only accept things like time series analyses or time series data sets that have a specific increment steps? You know what I mean? Or do you accept any kind of data that goes down a core or something like that?
It can. I guess. Are you asking, does it have to be sort of a transect of measurements across some sort of physical sample, or does that transect have to be regular?
Yes, but a little bit of both. So does it have to be regular, and is there a minimum increment, or if we have data set every 25 centimeters, is that a quote unquote not good enough type of data set, or?
That's fine.
Yeah, is there some kind of criteria?
No, we don't judge.
Okay.
It's a judgment-free data format. It really, I mean, any sort of transect, whether it's irregular or low resolution or high resolution, whatever, that doesn't matter. Essentially, if it can be represented at the table, it fits nicely.
Mm-hmm. Okay, well, that's good enough. That works well. And something that I would like to bring up is we've been successful. Yeah, I wanted to tell you one more thing in terms of what are your next activities. I'm curious if you have some plans in organizing maybe a session or a half day where we could meet, not just the two of us, but anybody interested in Lipid, and just sit down and write a bunch of scripts or ingest a bunch of data sets together. And I'm suggesting that because we've been doing that with CPEAT and with the Soil Carbon Network, and it's been working quite nicely to just bring people together and just, hack data for a day.
Yeah, this is something that we've been discussing sort of informally with Pages, but that I think that it would make a lot of sense, especially if more working groups are thinking about trying to take this on, is to organize something once a year or where sort of people that are involved with sort of the nitty-gritty data management stuff from different working groups can all get together either in person or electronically and work through questions and issues and best practices and methodology. That's something I'd really like to do, but that we don't have any formal plans for yet, but that hopefully will emerge in the coming months.
Great. All right. Thank you very much, guys.
Thanks, Julie. Yeah, and before we lose it, Kate had a question in the chat side of things, also on the theme of training on Lipid. Can you point us to a set of examples that reflect different types of data sets?
Yeah, I mean, I guess so we're working on developing a large set of examples, especially sort of, and more generally, my sort of most proximal activities is formalizing and doing the first. It's available now, but doing sort of the first big release of GeoCronar, which is really focused for more so than not sediment data with lots of radiocarbon dates, or well, with radiocarbon dates. That includes examples like some of the ones I showed in the presentation, and a handful of other ones. I really would, one of the other things I'd like to do with that Lipidiverse site is to develop sort of a large library of examples of people handling this in different ways. So that can be sort of time consuming, but on the other hand, I think examples are one of the most effective ways of both communicating what we can do and training people how to do it.
Great. Let's see, Gene, I think you're back with your hand up, and maybe while he's asking his question, if any of the participants would like to now join in, please go ahead and raise your hand, and Lucian will be working behind the scenes to promote you as presenter, so you can activate your mic, and feel free to use the chat as well.
Yeah, thanks,
go ahead,
Darrell.
Gene.
Nick, I just wanted to piggyback on your thought about, some kind of, say, annual or whatever the time period kind of meeting would be amongst different data managers and all. And I was thinking that's a great idea, and it would be really cool to include like the World Data Service, Neotoma, perhaps Pangea, the large archive entities in those kind of meetings as well. So I just wanted to mention that.
Great, thanks, Gene.
So the floor is still open here for additional questions. One coming through here from Boris. Go ahead, Nick.
Thanks, Boris. Yeah, back on. So yeah, I mean, I guess if I understand your question right, Boris, I'm not sure if the question is, can we try to make like the global paleo fire or the global charcoal data set compatible with lipid while also sort of maintaining a separate front end? And absolutely, I mean, and it doesn't necessarily need to supersede anything, right? It's if we are able to develop a conversion. Either one way that just goes straight from your database into lipid, that should be, my hunch is that's being pretty straightforward. I don't know about going back the other way, how easy that would be or not. They could sort of both exist, right? And then they could serve different purposes while sort of be existing in parallel. This is sort of also the model with like Neotoma, and then Neotoma has similar models with other sort of databases, right? Is that once the data are structured, then converting back and forth or converting one way is relatively straightforward, and then we can sort of take advantage of what lipid offers in terms of comparing and being able to integrate those data with data sets from other sources, while also being able to maintain the utility of the current structure you have. And that's something that we're with more generally, especially for people that already have data formats developed, I think it makes a ton of sense and is a win-win.
Great, and Rafaela has a question, I think, about whether the current data set includes SSTs and CI16.
Yeah, so we have a handful. I would say not much sea ice data. We do have some sea ice data, although most of that I would say is in the Arctic currently, and then a handful of Holocene scale SST data. We don't currently have much data that extends beyond the Holocene yet, because that's really been the focus of the people who have been working on projects has been more Holocene. That said, I've done research on last interglacial SSTs through the present, and I probably could take the data that I have and convert those relatively easily. And there's other people that are doing sort of similar things. Just Tierney and Brewster, I don't know if either of them are here, are also working on a data assimilation project for the LGM, and they're collecting a lot of data, and we've been in touch with them about trying to integrate what they've been doing with lipid, and I think that will likely happen also. So yeah, it's all of us, I assume, I don't know all of you, I assume most of us here are sort of scientists, and we're sort of driven by scientific questions, and so and you know, the goal is we're not just going to sit down and say, okay, let's convert every data set we can find into this format just because we want to do that. It's really going to be driven by sort of scientific inquiry. So as we have projects to address certain things, that's sort of how data sets have been getting in traditionally, and that's how I envision most of the data coming in the future as well.
Okay, thanks, Alicia, for joining us. Other questions for Nick? Either raise your hand or go ahead and type into the chat window. Let's see. I think our goal was to wrap up in an hour and a half, and we're just 5 or 10 minutes from that. So maybe no other questions. Maybe, let's see, maybe while in case there might be any questions coming through here in the next few minutes, let me just, yeah, thank you, Eugene. Let me just introduce a short topic to wrap up here, and that is this being the first Pages webinar. We'd be really interested in having your feedback. How you felt the format worked, if you have ideas for future seminar topics. Lucy and I and the steering committee would really like to have that input. You can do that by raising your hand now, by typing into the chat window, or in the next day or two, if you could send your thoughts to the Pages International Program Office. So just log on to the Pages website and you'll find a connection there for the Pages IPO. So yeah, we want to make this a regular event, and we want to make sure it's going to be most useful for all of those who are interested in. So does somebody, let's see, Thomas, I think you have a fresh new hand up, I believe, and maybe Jean.
Yes, I was just scrolling through the inferred observation times and proxies, and of course, Pages is I would say 80 or 90% on climate change, and the question was how far have you considered human change, human impacts? Because what we are mainly interested in change is how strongly have humans altered soil erosion and sediment. So are there any data sets in that already which consider the human impact or human impact factors or something like that?
Not in lipid. Yeah, I don't think so. And you know, depending on the structure of the data set, it may or may not make sense for lipid. If it's sort of, if it's like an inference drawn from something you've measured from a environmental, you know, some sort of physical sample. We've also been working on conceptually how thinking about like documentary, historical paleoclimate or other information data, and how to get that in lipid, which is a bit more challenging because the structure is a little bit different, but actually it does work conceptually. Things like that could work well. I guess I don't know the extent to which what you're describing is like, you know, data sets and observations versus sort of interpretation, and whether if it's sort of more on the interpretation side, it can be embedded, associated with as an interpreted field or as a you know, sort of a metadata describing something. If it's more sort of analysis, then you know, that may be better suited elsewhere. I guess I always just need a better sense of what exactly it is you're looking to archive and why to be able to answer that question better.
Yeah, I mean, important question also for the land use changing groups in Pages is certainly how can we use pollen records to infer human impacts, and certainly it's more complex than just climate changes and inferring climate changes. But yes, I think the groups which certainly focus on human impacts, like our group and the land use group, should think about how we can get this the humans into LiPD.
Yeah, I mean, so I guess what I think that would work well if I'm understanding correctly. So I'm imagining you have some sort of like a pollen data set, and rather than trying to infer temperature from that, you're trying to infer sort of the extent of cropland or sort of in an area, and you have some sort of either qualitative or quantitative methodology for doing that. That would conceptually fit really well. So we my background is in paleoclimate. We focus there, but all of the everything we've done is general enough that there's different types of interpretations you could have. There's different types of models, and so whether it's you're trying to infer human impact, or whether you're trying to infer climate, that would fit in all the tool. Everything would work the same way.
Yeah, great, thanks.
Great, yeah, thanks, Thomas. And we started the webinar series with a topic, focused on data, and in part that's because it is a common theme for a number of the working groups. But maybe for the next webinar, we should be looking at something involving human impacts, and it doesn't necessarily have to be on the data side of things. So, in the last few minutes, if there is some ideas, some suggestion, any discussion at all regarding future ideas for webinars, changes for this format, we'd love to hear them now. Okay, well, if anything comes to mind, make sure that you get a hold of me or Lucian or somebody at the Pages IPO. Okay, so I think we'll go ahead and wrap this up. I want to thank Lucian for managing behind the scenes there with the technology. I want to thank all the participants and those of you who asked questions, and especially like to thank Nick for his wonderful presentation. So thank you all for coming, and I'm looking forward to seeing you at the next Pages webinar.
And we will post some links. So I know that this was recorded. There's a number of links I referenced in my talk, both to especially to some of those like markdown workflow documents. I will send those on so they can be included. So if you want to refer to those later, you can.
That's a great idea. Thanks very much, everybody.